When we're adding and subtracting fractions, we have to make sure we have a common denominator. Now, basically a common denominator means that we have the same shape fractions or same size pieces of fractions. Okay, so another way we can think of common denominator is that they share the same factors, the multiplying pieces in the denominator. So if I want to show that I have common denominators, I can look at the factor pieces. So this is times 2 times 3 minus 1 over 2. Now this is missing a times 3. So I'm going to then introduce a times 3 factor here to make it a common denominator. And I need to make sure I have a times 3 here. Okay, so the common denominator ends up being 1/6. Now, I've kind of shown this in 12ths, but we could use 1/6 pieces because we can just do 1/6 here. Okay, maybe I'll split this up with the black. Okay, so we have our 1/6 pieces like that. Okay, here my 1/2 can be made into 1/6 pieces like this, and you can see that we have 3 1/6 pieces. So now that we have our common denominator, we can just add this together. So 5 minus 3, we end up with 2/6. So when I subtract these, I'm going to be left with 2 1/6 pieces here, these two here, and then we can simplify that to 1/3. So the factors are really important when we're dealing with rational expressions. We need to understand all the times pieces that make up the fractions. So here, when we do the times and divide or times and add, first of all, we have to do BEDMAS, so we have to make sure that we multiply first before we add. But really, when we talk about fractions, times really means that this is really just one fraction times on top, divide on bottom. So I can just look at this as 7 over 6 plus a 7a over 24x. And then I just have to ask myself, and again, this is to do with the factors. What factors will make these the same? Well, the left-hand fraction is missing a factor of 4x. And that would make the denominators share the same factors. If I make the top 4x, then I balance a fraction and I end up with 28x plus 7a. Those are unlike terms, so we can't combine them. And that is all over the common denominator of 24x. So there it is. Okay, the idea then is to look at, just like with up here, what's important is understanding the factor pieces that make up these rational expressions. Okay, so here's some rational expression problems. Okay, so Jonathan can complete a job in 6 days and Kelly can complete the same job in 4 days. How long will it take for them to complete the job, same job working together? Well, we can just add them together and say it takes 10 days, but that doesn't make sense because if they're working together, it should take us less time than 4 days. Okay, so this is how we need to look at this problem. We need to actually look at this as the rate. So I'm going to write Jonathan here. So Jonathan, he can do one job in 4 days. And Kelly can complete the same one job in 6 days. Okay, well, to be able to add these together, combine this together, in essence, we're going to add up the speed of which they work. And their speed together will get the job done faster. So if I want to add these two rates together, I need a common denominator. Well, the common denominator is 12 days. So how many jobs can they get done in 12 days? Well, in 12 days, Jonathan can get 3 jobs done. And Kelly can get 2 jobs done in the same 12 days. Now that we have a common denominator, we can actually add these rates together and say that together they can get 5 jobs done in 12 days. Well, if that's the case, how long will it take to get one job done? Okay, well, basically, if it takes 12 days together to get 5 jobs done in one day, well, that's really a unit rate. To get a unit rate, we divide. So if I do 12 divided by 5, I'm going to end up with 2.4 days to do one job. And so the answer will be together, it'll take them 2.4 days together. That kind of makes sense because if they can work the same speed, 4 days for one job, they would half the work, which would be 2 days. So it won't be quite half. It'll be a little bit less than half or a little bit more than half the time that they would take for, in this case, Jonathan or Kelly to do in one day. I think I had these backwards, didn't I? So Kelly was 4 days and Jonathan was 6 days. Okay, so here is another problem here. So we have in Henry's math class, his text mark is worth 90%, 5% of the term. And his homework's worth 5%. His test marks is 70%. His homework mark is 90%. What's his term mark? Well, there's a few different ways we can look at this. If we take a look at his 100% mark, so that's the total mark, 100% total. We know that 5% is homework, and we know that 95% is test. So of this 95%, he got 70%. His test marks is 70%. So we need 70% of that 95%. Okay, so I'm going to say that that's about 70% of 95%. And that's going to equal, in terms of the 100, if we want to talk about the whole, really this is 70% of 95%. Well, we know that's going to be a multiplication statement. So that's going to be 66.5% of the whole. And of the 5%, we know that he got 90%. So we want 90% of the 5%. Okay, well, if we want 90% of 5%, we just do 5% times 90%, and that's going to give us 4.5%. So what the blue represents it is the amount of marks achieved out of 100%. So together, so the marks achieved is going to represent, well, 66.5 from the tests, 4.5 from the homework, and so he ends up with 71% mark overall, which is, his homework mark is going to bump up his test mark a little bit. Now, since its homework wasn't worth very much, it only bumps it up 1%, but it bumps it up.